Today we're diving into the world of refactoring, a crucial practice for any developer who wants to keep their codebase healthy and adaptable. Refactoring is the process of restructuring existing code without changing its external behavior. Think of it as tidying up your workspace. You're not adding new features, but you're making everything easier to find and use. This practice helps you understand your code better, reduces bugs, and makes future changes much simpler. Throughout this video, we'll explore why refactoring matters, when to do it, and how to approach it with confidence. Might wonder why spend time refactoring when you could be building new features. The answer is simple. Code bases grow messy over time. Without regular refactoring, your code becomes harder to understand, more prone to bugs, and slower to adapt to new requirements. Refactoring keeps your code clean, making it easier for you and your team to add features, fix bugs, and onboard new developers. It's like regular maintenance for your car. Ignore it, and you'll pay the price down the road. It's important to distinguish between refactoring and rewriting code. Refactoring means improving the structure of your code without changing what it does. Rewriting, on the other hand, involves throwing away the old code and starting from scratch. Refactoring is less risky and more incremental, allowing you to keep your code working at every step. It's about making small, safe improvements that add up over time, rather than betting everything on a big rewrite. And Beck introduced the idea of the two hats in software development, one for adding new features and one for refactoring. When you're wearing the feature hat, you focus on delivering new capabilities. When you switch to the refactoring hat, you focus solely on improving the code structure. It's important not to mix these activities. Refactor first if the code is messy, then add your new feature. This separation keeps your changes safe and your codebase healthy. Factoring isn't something you do just once, it's a continuous process. The best time to refactor is right before you add a new feature or fix a bug. If the code is hard to understand or change, refactor it first. This makes your actual change easier and less error-prone. Remember the rule of three: the first time you do something, just do it. The second time, notice the duplication. The third time, refactor. One of the key principles in refactoring is to make small, incremental changes. After each small change, run your tests to make sure nothing broke. This tight feedback loop helps you catch mistakes early and makes it easy to revert if something goes wrong. By taking small steps, you keep your codebase stable and your progress steady. Tests are your safety net when refactoring. Before you start, make sure you have a solid suite of automated tests that cover the code you're about to change. These tests should be self-checking, giving you immediate feedback if something breaks. If you don't have tests, write them first. Good tests make refactoring faster, safer, and more enjoyable. One of the most common refactorings is extract function. If you find a chunk of code that does something specific, pull it out into its own function and give it a meaningful name. This makes your code easier to read and reuse. Extracting functions also helps you break down large, complex routines into manageable pieces, making future changes much simpler. The opposite of extract function is inline function. If you have a function whose body is as clear as its name, or if it's only used once, consider inlining it. This reduces unnecessary indirection and makes your code easier to follow. The key is to keep your codebase as simple and direct as possible. When you see a complex expression, extract it into a well-named variable. This makes your code more readable and gives you a convenient place to add debugging or logging. Good variable names communicate intent and help others and your future self understand what's going on. Never hesitate to rename a variable if you find a better name. Clear, descriptive names are one of the best ways to communicate your code's purpose. With modern tools, renaming is quick and safe, so take advantage of it to keep your code expressive and understandable. Encapsulating variables means controlling access to your data through getter and setter functions. This gives you a single place to add validation, logging, or other logic. It also makes it easier to change how your data is stored or accessed in the future without breaking the rest of your code. Sometimes, your code is doing too many things at once. Split phase is a refactoring where you separate different stages of processing into distinct functions or modules. For example, you might first parse input data, then process it, then format the output. This separation makes each phase easier to understand and modify. If you find yourself writing long switch or if else statements to handle different types or cases, consider using polymorphism. By creating subclasses or strategy objects, you can move the specific behavior into the right place. This makes your code more modular and easier to extend in the future. How do you know when to refactor? Look for bad smells in your code, signs that something could be improved. Common smells include duplicated code, long functions, large classes, and mysterious names. When you spot a smell, use the appropriate refactoring technique to clean it up. Over time, you'll develop an intuition for when your code needs attention. Naming is one of the hardest and most important parts of programming. Good names make your code self-explanatory, while bad names create confusion. Don't be afraid to spend time finding the right name for your functions, variables, and classes. Your future self and your teammates will thank you. Common worry is that refactoring will slow down your code. In reality, well-structured code is often easier to optimize. Focus on clarity and structure first. If you find a real performance bottleneck, you can optimize that specific part later. Most of the time, the benefits of clean code far outweigh any minor performance costs. Modern IDEs and editors offer powerful automated refactoring tools. These tools can safely rename variables, extract functions, and move code around with just a few clicks. Take advantage of these features. They make refactoring faster, safer, and more enjoyable. But remember, always have tests in place to catch any unexpected issues. Refactoring is even more important when working in a team. Clear, well-structured code helps everyone understand and contribute effectively. Make refactoring a regular part of your team's workflow. Encourage code reviews that look for opportunities to improve structure, not just catch bugs. Legacy code, old code without tests can be intimidating to refactor. Start by adding tests around the parts you want to change. Use small, safe steps and lean on your tests to catch mistakes. Over time, you'll transform even the messiest legacy code into something clean and maintainable. Most effective refactoring happens in a steady rhythm. Make a small change, run your tests, commit your code, and repeat. This cycle keeps your codebase healthy and your progress steady. Remember, the true test of good code is how easy it is to change. By making refactoring a habit, you'll build software that's robust, adaptable, and a joy to work with.